Today we have learned about instrumentation of mass spectroscopy. This instrumentation divided in two parts. This PPT presentation contains first part of instrumentation of mass spectroscopy. A mass spectrometer consists of the following basic components. The schematic diagram is given in the PowerPoint slides. So, the mass spectrometer consists of the basic components are first sample handling system, second ionization chamber, third ion separator or mass analyzer, fourth ion collector, detector and readout system, and fifth component is vacuum system. Now we have seen one by one of the components. First component is sample handling system. The purpose of the sample handling system is to introduce the sufficient quantity of the sample into an ion source at constant rate without disturbing the vacuum. A micromole sample in gaseous state is slowly allowed to leak into ionization chamber. The pressure of the sample in the reservoir is greater than the ionization chamber to maintain the steady flow of gaseous sample. For different types of samples, different sample inlet systems are used, in which first inlet system is heated inlet system. This type of inlet system is generally used for gaseous and less volatile liquid samples having boiling point less than 500 degrees Celsius. In heated inlet system, the sample is vaporized externally and then slowly introduced into ionization source. Many types of vacuum locks are available for introducing sample into ion source without breaking the vacuum. The volatile liquids are handled by freeze out technique, wherein the sample in the sample holder tube is frozen with the liquid nitrogen or dry ice, and after evacuation the tube is heated to room temperature or higher to evaporate the sample into sample reservoir. Low volatile samples like sugars, acids, amino acids, etc. are converted into volatile derivatives. For example, hydroxyl compounds into ethers, acids, to esters, etc. Second inlet system is direct inlet system. Solids, non-volatile liquids and thermally unstable compounds are directly introduced into the ion source by means of sample probe, which is inserted through a vacuum lock. Usually, the provision is made for both cooling and heating of the sample on the probe, whereby sample can be slowly vaporized in the electron bombardment region. In this case, only a fraction of milligram or less of the sample is required to record the spectrum. Thermal decomposition of the sample is also eliminated in this technique. The non-volatile samples like steroids, polymeric substances, carbohydrates can be handled by this method. Now, third inlet system, gas chromatographic technique. In gas chromatography and mass spectrometry, the sample requirements are similar. Hence, effluents from a gas chromatograph can be collected separately and analyzed in the fast scanning mass spectrometer. Thus, gas chromatographic equipment can be directly coupled with rapid scan mass spectrometer. The flow rate from capillary column is generally low enough to be fed directly into the ionization chamber of the mass spectrometer. Now we have seen second component of instrumentation of mass spectrometer is ion source. Ionization of the organic compound is the primary step in obtaining the mass spectrum. The minimum energy required to ionize the sample or organic molecule is called as its ionization potential. Several methods are available to induce ionization of organic compounds. Ionization of the vaporized sample may be produced by the electron bombardment, field ionization, thermal ionization, chemical ionization, photoionization, or vacuum discharge ionization. Some of the common ion sources are discussed below, in which first source is electron impact ionization source. In this, electron bombardment is the standard and most commonly used method of ion production. In this method, the bombarding energetic electrons are produced from electrically heated tungsten or rhenium filament. These electrons are accelerated by an electric field to average electron beam energy of about 70 electron volt. This sample pressure is about 10 raised to power minus 5 to 10 raised to power minus 6 torr. The vapor of the sample to be analyzed is introduced at right angle to the electron beam through a molecular leak. Energy transfer takes place between the neutral sample molecules and bombarding electrons. If the transferred energy is equal to the ionization potential of the sample, ionization takes place. Ionization potential for the most of the organic compounds varies between 8 to 12 electron volt. The electron impact process suffers from the drawbacks that the sample first needed to be vaporized. This may result in the thermal decomposition of a part of a compound. Besides ionization and fragmentation, it may lead to complete destruction of the compound. Now we have seen second ionization source, field ionization source. In field ionization, the molecules and the atoms are ionized by evaporation over a potential barrier on the surface due to strong electric field, that is 10 raised to power 8 vacuum per centimeter. These strong electric fields are produced by using specially formed anodes of fine tungsten or other materials. The field ionization anode and cathode are arranged with a very fine gap, that is 0.5 millimeter to 2 millimeter, which may serve as a slit. The gaseous sample introduced at the anode points where the electric field is concentrated. The ionization of the sample takes place by extraction of electrons from the sample by the microtips of the anode. In this process, fragmentation is less, leading to molecular ion as a major product, which may be considered as advantage over electron impact ionization process. Now we have seen third ionization process, that is chemical ionization process. The principle of chemical ionization is the use of ion molecule reactions. In this technique, the gaseous sample is introduced into the ionization chamber at a pressure of 1 torr. The primary ionization of the sample is effected by impact with positive ions produced by electron impact method. Due to high pressure, the primary ions undergo ion molecule reactions with the neutral molecules of the sample.